Good morning, students. Today we learn class 9th physics. The name of the lesson is Force and Laws of Motion. We have already learned the first law of motion and the new term related to the first law of motion, inertia. The first law of motion is also known as law of inertia. Second law of motion. Before starting second law of motion, we have to know a new term known as momentum. What is momentum? What is the formula of the momentum? The formula of the momentum equals to P equals to M into V. Momentum equals to mass of the body and velocity of that given body. How this formula come into existence? First we have to know about that. Suppose we have two stones of 1 kg and 2 kg. We take that stone and climb up to the roof of our house. Then after we drop one by one these stones. First we drop the 1 kg stone from our house roof. Another boy catching that stone or want to catch that stone of 1 kg. Then again we can drop the stone of 2 kg. It will found that more force is required to stop the 2 kg stone. Here more force is required. So from here we can say that or we conclude that the force required to stop a moving body is directly proportional to its mass. The force required to stop a moving body or object is directly proportional to its mass. Force is required force. The required force is known as momentum. So here we can say that momentum is directly proportional to the mass of that object or stone. From above example. Then the same example of a stone we have take. Suppose we throw the 1 kg, suppose the stone are of same masses. The second part, if both stones are of same mass, we throw it by the roof of our house one by one. This is the first stone. The velocity of the first stone is suppose 2 meter per second. And the velocity of the second stone is 5 meter per second. Both stones are of same mass. Same mass. From here, if the velocity of a body increases, more force is required to stop the body. From here, again, we can make a conclusion. The force required to stop a moving body or object is also directly proportional to its velocity. From these two cases, we can say that the momentum is the momentum is the product of mass and velocity of a body or of that body or object. So here we can write momentum equals to mass into velocity. Momentum is represented by P equals to M into V. P is momentum of a body, M is mass of that body, V velocity or speed of that body. Okay, this is the result we got. Here we can say that momentum is directly proportional to velocity. From here, if somebody asks us what is the momentum at the rest condition, if a body is at the condition of the rest, the velocity of that body became zero. So there is no momentum. So momentum is also became zero at that time. Okay. The SI unit of momentum for M we can use kilogram. Velocity meter per second we already know, so M kilogram meter per second. It is the unit of momentum. Unit of momentum. So we start our second law. Newton's second law of motion. Suppose we have two balls, one made up of iron this is an iron ball and other one is a plastic ball. The force acts on both the ball at the same time. The light ball attain higher velocity or higher speed. Why it is happen? Due to momentum. From here we can say that there is a link between the force and the momentum. This is Newton's second law of motion. According to Newton's second law of motion, the rate of change the rate of change of momentum of a body or ball or object is directly proportional to the applied force and takes place in the direction in which the force acts. Okay, the rate of change of momentum can be obtained by dividing change in momentum by time taken. So, second law of motion, force is directly proportional change in momentum upon time taken. Okay, you have to know about that one. Force is directly proportional to change in momentum upon time taken. Let us take example. Suppose a bus moving on the road when the bus is at a point A. It has mass m and the initial velocity of the bus is u. After some time, when it reaches out to position B, the mass is constant, so it remains m, and the velocity attained by the bus is v. So, mass equals to m Initial velocity u and the final velocity equals to v. Change in momentum is final velocity subtracted by initial velocity. Final velocity of the bus is this one, mv, or final momentum of the bus is mv, and initial momentum is mu. M is common, v subtracted by u. This is the change in momentum. Suppose change in momentum is represented by P, where you got the change in momentum. So we can say that force is directly proportional to change in momentum. M v minus u upon time taken t. We know that acceleration equals to change in velocity upon time. Acceleration equals to change in velocity upon times taken. So F is directly proportional to ma. In place of v minus u upon t, you can put a. Okay. Then here we can replace the sign of constant proportionality, and the constant should be introduced. F equals to k ma. The value of k in SI unit is 1. K equals to 1. So force equals to ma. Mass into acceleration. From here you can say that force, therefore force equals to mass of the body into acceleration. Gained by that body. Thus, Newton's second law of motion gives the relationship between force and acceleration. Force equals to mass into acceleration. Thus, Newton's second law of motion gives us the relationship between force and acceleration. Applications of Newton's second law of motion. A cricketer play on the ground when he takes the catch, he take his hand in the backward direction. Why he take his hand on the backward direction? To reduce the momentum. A fast moving cricket ball has large momentum. In stopping or catching that ball, its momentum has to be reduced to zero. Okay? That's why he can take his hand on the backward. There are so many other examples in our daily life. So, the second example, when the high jumper during the athletic meet or in practice section, the ground where he fall is made up of cushion or sand. When he falls down in the cushion reduces the momentum. That's why he do not get injured. If this video is interesting and you learn from this video or you like it, subscribe it and share it. Thank you.